Right, so in this video I'm just going to have a look at the Junior Cert Higher Level Maths Paper 1 2017. I'm going to have a look at questions 6 and 7. So this is question 6 here, and it's to do with Venn diagram, filling out a Venn diagram. So we're given some information here, and we've got to fill out this Venn diagram down below here, given this information. So let's have a look. Each of the students in 6th year in a particular school has WhatsApp, Instagram or Snapchat. The number of each app are as follows, and they give you the information here, and then they give you a Venn diagram, 3-set Venn diagram. Use this information to fill in the Venn diagram in terms of X. So let's do that. Let's start. 36 students have WhatsApp. Well, this is our WhatsApp circle here. We can't fill in 36 anywhere there really, because it's divided into 4 sections, so we don't know how to divide up that 36. So what I normally do here is just stick in maybe 36 here, just to remind me how many students have WhatsApp. Next part, 40 students have Instagram, so same thing again. So I'll just put 40 here. Can't fill it in anywhere here. So next one is 54 students have Snapchat. So 54 students have Snapchat. I don't know how to divide that up, so I'll just write it in here for the moment. Okay, so let's have a look. 14 students have WhatsApp and Instagram. 14 students have WhatsApp and Instagram. So that's going to, the 14 students are going to go in here somewhere. This is the intersection of WhatsApp and Instagram. But how do we divide up that 14? We don't know. So I don't know how to put in, or where to put in that 14, or how to divide it up. So I can't do anything with that 14 at the moment. 24 students have Instagram and Snapchat, so same thing again. I can't divide that 24 up. Now X students have WhatsApp and Snapchat, but not Instagram. So X number of students have WhatsApp and Snapchat. So that's this circle here and this one down below here, but they don't have Instagram, so I can take this out. So now I know I can put in an X here. So this is WhatsApp. This is the number of students who have WhatsApp and Snapchat, but they don't have Instagram. So it's only this section here I need to worry about. So this is my X here. Okay, last thing to say here is 8 students have all 3 apps. So 8 students have all 3 apps. So I can put 8 in the middle here. Okay, so let's go back to the beginning then and see if there's anything we can do at this stage. Well, the first 3 lines here just tell us these 3 totals. So I can't do any more with those at the moment. So let's have a look at this line here. 14 students have WhatsApp and Instagram. WhatsApp and Instagram. So 14 students have WhatsApp and Instagram. Now I know that 8 students will be in this section, so that will leave me with 6 students in this section here. 6 and 8 give me 14. So this is my 14 students who have WhatsApp and Instagram. 24 students have Instagram and Snapchat. 24 students have Instagram and Snapchat. So in here there should be 24. We've accounted for 8, so that means we must have 16 here. 16 and 8 will give me the 24 students who have Snapchat and Instagram. Okay, so now at this stage we just have to fill out this part, and this part here. So how do you do that? Well, we know that 6 plus 8 plus X, if we add those 3 together, subtract them from 36, that'll give us this part here. So what you get there is 36 minus 6 minus 8 minus X. That will give me 22 minus X. Here if we add up 6, 8 and 16 and subtract from 40, we'll get 10. Here if we take 54 minus 16 minus 8 minus X, that will give me 30 minus x. Okay, so that's it. This is our Venn diagram filled in terms of x. So usually what they do now, and I think they do down here, is they ask you to find out what x is. So in order to do that, they tell us that there are 80 students in total in sixth year. So all of these numbers here need to add up to 80. So let's just work all that out. So what I'm going to do is say 22 minus x plus 6 plus 10 plus x plus 8 plus 16 plus 30 minus x, all that equals 80. That's my equation, and I'm going to solve that. So let me just write all that out. So I have 22 minus x. Oops. Okay, 22 minus x plus 6 plus 10 plus x plus 8 plus 16 plus 30 minus x. These are all the sections of my Venn diagram. They should all add up to 80. So this is my equation. I've only got one unknown in this equation here, it's x. So I can isolate that x. I can work out what that x is. So let's do that. If you add up all the numbers, 22 plus 6 plus 10 plus 8 plus 16 plus 30, you get 92. If you add up all the x's, you've got a minus x plus x. So that will just give me 0. And I'm left with a minus x here. And on this side I still have the 80. Okay, almost there. Now I'm going to subtract 92 from this side. I'm going to subtract 92 from this side. So it's minus x is equal to 80 minus 92. So that gives me minus x is equal to minus 12. So that just simply gives me x equal to 12. What were we asked to find? Find the value of x. We've done that. Okay. So that's that part of the question finished. Let's move on to the next part then. So we're given this table here, and in the table here we're told that there are statements and mathematical notation. So we've English statements down along here, and we've got their mathematical notation equivalents down here. And we have to complete the table. So let's see, what have we got? In the first case here we have 8 is equal to the cardinal number of w intersection I intersection s. So what does that mean? Well, it means the intersection, the number of students who have WhatsApp, Instagram and Snapchat, who have all three, is 8. So we would just write 8 students have all 3 apps. 8 students of all 3 apps, or some version of that anyway. Okay, let's look at the next one then. 24 students have Instagram and Snapchat. 24 students have Instagram and Snapchat. So that would be the cardinal number of Instagram, and this word "and" here means intersection, and Snapchat. So we have Instagram and Snapchat, and that's going to be equal to 24. Next one. Okay, we have 10 here is equal to the cardinal number of the number of students who have Instagram but not WhatsApp or Snapchat. So we've got the combination of these we've got to kick out. We're just left with the number of students who have Instagram only. That's what this means here. It's the number of students who have Instagram only. The number of students who have Instagram but not WhatsApp or Snapchat. So let's just write that down. So it's 10 students. 10 students have Instagram. But not but not WhatsApp or Snapchat. Okay, so this word or here would be related to this U here, this symbol here, U, and remember and here is related to this symbol here, intersection. Or the other way you could say this is 10 students have Instagram only. So 10 students have Instagram only. Okay, and the last one, more students have Snapchat than have WhatsApp. Well, that could be written, let's see, the cardinal number of students who have Snapchat would be greater than the cardinal number of the students who have WhatsApp. The number of students who have Snapchat is greater than the number of students who have WhatsApp. So you can write it like this. Okay, so that's that question finished. Let's have a look at question 7 then. Okay, question 7. Give an example of two non-empty sets A and B for which A intersection B is equal to A. Okay, so there are lots of different examples you could give here. I've just decided to give a mathematical one, so it would look something like this in terms of a Venn diagram. So you would have B here, the set B here, and then you would have the set A inside it. So this is, if you do A intersection B, you would just be left with A here. So what examples can we give? Well, we could say that A is the set of all natural numbers. A is the set of all natural numbers, and you could say B then could be the set of all integers. So if A is the set of all natural numbers, B is the set of all integers. So in here you would have positive numbers, positive whole numbers. Out here you would have the negative numbers, negative whole numbers out here. So A intersection B then would just be the positive whole numbers. So that's one example. Okay, there are other examples you could probably think of, but let's just move on to the next part here. Give an example of two non-empty sets P and Q for which P less Q is equal to P. So let's see if we can think of examples of that. So let's see, this it would probably look like this here, where you would have the set P and the set Q. So there's no overlap here, they don't intersect. So the set of P less the set Q would just be the set P, because there's nothing from Q in here to get rid of, if you like. So let's see, you can say that P is the set of, P could be the set of irrational numbers, for example. So that's written or less Q. That's the way we would write irrational numbers. And then you could say Q here is the set of rational numbers. So a number is either rational or irrational, so there's no overlap, they can't be both. So the set of irrational numbers less the set of rational numbers is just the set of irrational numbers. I don't know, another example you could probably use is maybe P could be the set of, in a pack of cards, P could be the set of red cards. Q could be the set of black cards in a pack of cards. So the set P less Q then would just be the set P. The set of all red cards less the set of all black cards is just going to be the set of all red cards, again because there's no overlap here. Okay, so that's it for this particular video.